We've built a real distributed system, a gateway, two services, each with its own database, a message broker carrying events between them, and telemetry flowing out of all of it. Now the finale, and a very practical question. How do you run all of that on your laptop, wired together, without losing your mind? The answer is orchestration, and in .NET, that's Aspire. One command, and the whole topology comes up. Let's finish by running everything we built. Let's start with the pain, because it's real. Even our modest system has a lot of parts: a gateway, two services, two databases, a message broker, and telemetry collectors. And every one of them needs to find the others. The gateway needs the services addresses. Each service needs its database's connection string. Everything needs the broker. Do that by hand, with config files and environment variables and juggled port numbers, and it's genuinely chaotic. Miss a single wire, and something fails at startup with an error that tells you nothing useful. Running a distributed system locally has always been the tax you pay for splitting it up. Orchestration flips that around. Instead of wiring things by hand, you describe the whole topology in code. Here are my databases, here's my broker, here are my services, and here's who references whom. Then one command boots every process at once and does all the wiring for you. It provisions the databases and the broker and injects the right connection strings and addresses into each service automatically. And it uses service discovery, so your gateway refers to the project service by a logical name, never a hard-coded port that changes every run. You declare the shape, the tool handles the plumbing. In .NET, that orchestrator is Aspire, and this is its app host, the whole system, in about a dozen lines. You add a SQL Server container and give each service its own database. You add Azure Service Bus and tell it to run as a local emulator. So there's no cloud, no subscription, just a container on your machine. Then you add each service as a project, and WithReference wires it to its database and the broker. Aspire injects the connection strings. The gateway references the services by name, and service discovery resolves them. And that's it. .NET run, and the entire system comes up together. So here's everything we've built, running together. At the top, the gateway, authenticating users and minting internal tokens. Below it, members and projects, each trusting the gateway, each enforcing its own authorization. Members publishes an event when someone's invited. It travels through the Service Bus emulator, and projects consumes it into its read model. Databases, broker, telemetry, all provisioned and wired by Aspire. Everything from this whole series, on one machine, from one command. That's the payoff. And there's a bonus that matters enormously in distributed systems: observability. Aspire opens a dashboard the moment it starts, and every service streams its logs, traces, and metrics into one place, using open telemetry, wired for you by the shared service defaults. When a request flows through the gateway and into a service, you can follow its trace across that whole path, spans and all, which is how you actually debug a distributed system. And step back for a second. What's running in that dashboard is everything from this series. The trust boundaries and internal tokens. The multi-tenant, deny-aware authorization. The outbox, the inbox, the read models. All of it, together, on your laptop. So that's Aspire, and that's the series. We started at a trust boundary and asked who your service should believe. We minted internal tokens at the gateway and rotated their keys without downtime. We made every service multi-tenant and taught its permission contract to defend itself. We authorized across service hops, and we connected the whole thing with events, reliably out through an outbox, idempotently in through an inbox, answered from local red models. Then we ran all of it, wired together with a single command. That's a real distributed system, and every piece was compiler enforced, verifiable, and yours to build on. Thank you for watching Series 6. Subscribe, and I'll see you in the next one.